Okay, this video is for those of you who have not yet completed the 5.2 end behavior part of the notes. So we're going to talk a little bit about polynomial graphs and how they behave as we go really big in x, which we call that as x approaching infinity, and what happens when the graph approaches negative infinity, as x gets really, really negative. So we have 4 different options, and we're going to focus on the power, the degree of our polynomial. So you have to remember that the degree is the highest power in the polynomial, and then we also look at the leading coefficient as well when we're doing this. And we're looking at not the numerical value, but whether it is positive or negative. Okay, and we'll talk about as we get through whether or not, or how I know and what these things tell me. So we have 4 different options, and we're going to be focusing on whether the degree is even or odd, and then once I have that determined, whether the leading coefficient is positive or negative ultimately. So what do I mean by that? Okay, so we have, let's start with an odd degree. So that means that I have, for example, a polynomial that might look like this. Let's say 3x to the 5th power plus 3x squared minus x plus 5. Okay, so this is an odd degree because the highest power, which in this case is 5, is an odd number. So x to the 1st, x to the 3rd, x to the 5th, to the 7th, to the 9th, and so on and so forth being the highest power. Okay? So what I'm going to look at then, when we're talking about the end behavior, is what is this graph ultimately doing as x gets really, really big. So as x goes to positive infinity, what does the graph ultimately go to? Okay, so whenever we're doing a polynomial end behavior, I'm going to focus on the highest term. So the one that has the highest power, the degree, I'm going to use that whole term because ultimately if I plug in a number that is so big and so positive, that number to the 5th power times 3 is going to have way more effect on the graph than any of the stuff that follows after it. So I'm just going to focus on what the 3x to the 5th does. So I'm going to think of a really big positive number. 10 trillion. So I'm plugging in 10 trillion, and I ultimately want to know, what is this thing going to do? So if I plug in 10 trillion, I raise it to the 5th power, that's an even bigger number, and then I multiply it by 3. It's still positive, and if I got a little bigger than 10 trillion, 10 trillion and 1. That number is even bigger than the one before. So each value of x gets bigger towards infinity. This whole thing, and ultimately the whole equation, is going to get bigger. So it also goes to infinity. Okay, let's look at as x goes to negative infinity. What does the graph do? Alright, so now I'm going to picture, using that term again, putting in a negative number. Okay, so if I put a negative number in here, any negative number raised to an odd power is going to remain negative. So like negative 3 to the 5th power is negative 3 times negative 3 times negative 3 times negative 3 times negative 3. So I've got these two sets that become positive, and then I have a lonely negative 3 by itself. So this whole number right here remains negative, and then I multiply it by a positive 3. So it goes to negative infinity in this case. So a little quick picture. We don't, whatever's happening in the middle is fine, but ultimately as x gets really, really positive for this graph, so does y, and ultimately as x gets really, really negative, so does this graph. And then we have, the graph can do all kinds of stuff in between. Let's look at an odd degree again. But this time with a negative leading coefficient. So let's use the example f of x is equal to negative x let's do x to the 7th minus 4x to the 3rd plus x squared minus 5. All right, so if I focus on the negative x to the 7th, if I want to do my end behavior as x goes to positive infinity, then I can determine what does the graph y equals go to. So I'm going to focus on, so I've got -1, because that's what we can focus is on out in front here, and then I'm going to plug in a positive number and raise it to the 7th power. Okay, so in this case, a positive number, if I use my, please excuse my dearest Sally, my order of operations, this thing is a positive number to the 7th power is still positive, but then I multiply it by -1. So this is going to go to negative infinity then, because this number is the more positive it gets, the more the number that I plug in, the bigger it gets, but then I multiply it by negative, so it makes it get more and more negative. Okay, if I do negative infinity, I've got the -1 out in front. I plug in my negative number, so ultimately odd power raised to the negative number raised to an odd power is going to stay negative, and then I've got times -1, so this is going to become positive infinity. So it flips from the example above, before this. So we've got whatever's happening in the middle. As x gets more and more positive, the graph gets more and more negative, and as it gets more, x gets more and more negative, the graph gets more and more positive. So our odd degree then has one side that goes up and one side that goes down, every single one of them, and then the rest of the terms are going to determine, as we get farther into this, what's happening in between the end behaviors. All right, let's look at an even power now, even degree. So that means that our highest power is an even number, 2, 4, 6, 8, 10, and so on and so forth. So for example, let's use f of x is equal to 2x to the 6th plus 3x squared minus 5. I know these aren't the same ones in your notes. When we're done here, I'm going to have you can go ahead and fill in the ones in your notes, and then we'll check them as when I come around to work with you in class. So, all right, so if I look at end behavior for this one, as x goes to infinity, what does the graph do? So I'm going to focus again on the highest power. In this case, our degree is 6. Our leading coefficient is 2. So I'm going to do 2x to the 6th. Focus on that. So I've got 2 times a positive number to the 6th power. Okay, when I have an even power, no matter what's inside the parentheses, it will be positive. Positive number to the 6th power is positive, times 2 is still positive, and the bigger this positive number gets, the bigger this whole thing is going to get. So we're going to go to positive infinity. All right, let's try plugging in a negative number. So now if I plug in negative number, again, any negative number raised to an even power will be positive. So this is positive, and then I've got times 2. And as this gets more and more negative, -3, -5, -10, -20, and so on, this whole thing's going to be very, very positive. So both sides in this case get positive. So regardless of what's happening in the middle, both ends go the same direction. Last but not least, if we do even power, but with a negative leading coefficient, so let's do negative x to the 4th plus 6x squared minus 5. So I'm going to focus on the negative x to the 4th. So as x goes to positive infinity, we've got a -1 times a positive number to the 4th power. So ultimately this is positive times a negative gives me a negative infinity. Whoops. Now if I plug in a negative number, okay, so I've got -1 times a negative number to the 4th. Again, this whole thing is positive because it's raised to an even power, times a -1 keeps it negative. So again, our little picture, we don't really care what's going on in the middle right now. Ultimately, both ends are going to go to the negative side. So the leading coefficient and the highest power are what's going to determine what this graph looks like.